Hi everyone, welcome to my YouTube channel. My name is Avinash, and in this video, I'm going to discuss about possible interview questions on VPC service, VPC module. Right, so first, this VPC is a virtual network within our AWS account. Whatever the region you're going to take, defaultly you're going to get a VPC. We call that VPC as a default VPC. So now, if you scroll down to right, you can see there is a default VPC. So this is a yes, this is set to no. So this one I have created manually. This one AWS given automatically. So the question is, can we delete this default VPC? The answer is yes. So if you want to delete default VPC, you go and delete VPC. You just need to type, I want to delete my default VPC. If you don't have any running resources, it will delete automatically. So if you want to get it back, earlier we used to contact AWS, but now go to actions. The first option, create default VPC. With one click, we can get our VPC back. Okay. And the second question is, okay, what is the cidr range you're using for your VPC? And why that specific cidr range? Or the same question in different manner, like so, which cidr range you're using, and what are the things you're going to consider while you are selecting the VPC CIDR range? So, CIDR stands for classless inter-domain routing. So, based on this CIDR range only, we can launch the required resources in this VPC. So, if you are selecting slash 16, so it is going to give us 65,530 including zero, it's going to be give 65,536 IP addresses. Again, AWS is going to reserve 5 IP addresses. We cannot use that 5 IP addresses. Two is for DNS servers, one is for future usage, and one is network ID, second one is broadcast ID. So these 5 IP addresses AWS reserves. So apart from that 5 IP addresses, remaining all we can launch. For example, you just need only 5 IP addresses for a VPC. So then which subnet you want to use? So basically VPC supports minimum slash 28, maximum slash 16. So if you are selecting minimum slash 28, okay, let's take visual subnet calculator. So let's assume you are using 192.168.0.0 and minimum, as I said, slash 28, that's a minimum AVPC supports. We're going to get 14 IP addresses, but this is designed for regular network, so they are doing just -2. We need to do -3. So we are going to get 11 usable IP addresses whenever you're using this last 28. So yeah, that is the calculation. If you want to, if you want to launch around 1000 EC2 instances, so then which subnet we can use? If you are giving slash 22, we are going to get 1022 of IP addresses. Again, -3, still it is larger than 1000, more than 1000, so we can go with the slash 22. Again, yeah, fine. You're going to take this last 22 range or whatever range we're selecting. You're decided you selected and you creating your VPC. So within the VPC, how many subnets we need to create? So that depends. Again, in VPC we have subnets. So the subnets, right? We have public subnets as well as private subnets concept. So in simple, public subnet is internet facing one. Private subnet, it's an internal one, right? We cannot, if any resource is running inside a private subnet, we cannot access the resources over the internet. So then how we can access? So let's assume you have an EC2 instance in private subnet. How we can access or how we can get internet for that private subnet EC2 instances. So for that, we have an option called NAT Gateway. With the help of NAT Gateway, we can get internet or we can provide internet to all our private subnet EC2 instances. Again, these subnets, how we are going to segregate, you as observe here, I have two public subnets, two private subnets, two database subnets. So why we are creating two subnets? Can't we manage only one public subnet and can't we deliver? See, we always look for high availability. whenever you're using only one subnet, if something happened to that specific subnet, for example, public subnet 1A is running here in AP South 1A. If something happened to that AP South 1A, if my application is down, I'm going to get affected with that operation, right? So that is the reason for every subnets, it's recommended to choose or create at least two subnets across different availability zones for a high availability purpose, right? So that is a subnet concept. So then how we get internet for our public subnets with the help of internet gateway. You create an internet gateway, you attach that internet gateway to your VPC so that you will get internet to your public subnets. So how we define which are public subnets and all to which subnets you want to provide internet with the help of route tables. So route table help us to establish connectivity between components like internet gateway and um, and the subnets you associate here. And not only that, even you take any route table, we have an option called local route. So that means all the subnets I have here, see, observe here I have total six subnets running inside this custom VPC. These all six subnet EC2 instances can communicate each other. How it can communicate each other? All these subnets part of route tables, right? So those all route tables have a route called local route. So with the help of this local route, these all EC2 instances can communicate each other. So that question you can expect on route tables. So now the NAT gateway creation process, where NAT gateway runs and what is the purpose of NAT gateway? NAT gateway runs in our custom VPC's public subnet in one of the public subnet. If you want, you can create two NAT gateways, and or if you have multiple subnets, you can create NAT gateway in each and every subnet if you are looking for high availability. So again, if internet speed is less also, you can depend on multiple NAT gateways. But NAT gateway runs in our custom VPC public subnet and it provide internet to all our private subnet instances. Again, why we need internet for private subnet EC2 instances? To download some patches over the internet or to access some databases or some external endpoints, right? So we obviously need internet. For that internet, we can depend on this NAT gateways. We used to have an option called NAT instances. It still supports, but in real environment, we don't use much. The reason, a lot of additional operational overheads. We need to take care about operating system. We need to take care about security groups. We need to take care about source or destination check. Such type of lot of options are there. Because of those options, we really don't depend on much. So then next question is on pairings. So what exactly this pairing is? What is the use of VPC pairing? That one question. Or what is the process of pairing? What are the steps involved in that pairing connectivity? And another question, what are the pairing limitations? If you are creating a pairing, what are the things you need to take care? What are the limitations on VPC pairing? And some other questions like, can you create pairing connectivity between one region VPC to another region VPC? Or one region VPC to another AWS account. For example, account one VPC, account two contains another VPC. Can we enable connectivity between these two VPCs? The answer is yes. So this bearing connection designed to enable communication between multiple VPCs. So where these VPCs are doesn't matter. Your two VPCs may be in same region. If I want to enable communication between these two VPCs, yes, I can create a VPC pairing. Or one VPC is here in Mumbai region. Another VPC is in Northern Virginia or Singapore or Sydney, somewhere else. Still, you can enable connectivity. Also, I have this VPC in my account, Mumbai region. Another VPC is in different account, Mumbai region or Northern Virginia region, right? Still, you can enable communication. These all are the possible scenarios. Now, what is the limitations or what is a process? The limitation is your source or the request. Technically, if I'm creating a peering connection to a VPC, I'm going to call as a requester and that guy is going to call as a acceptor. right? So when I'm creating a peering connection, I should verify what is my VPC CIDR range and what is that acceptor CIDR range. If requester and acceptor CIDR range is same, okay, or if it is conflicting, we cannot enable communication. So technically, requester CIDR range and acceptor CIDR range should not collide. Okay, should not conflict. If it is conflicting, we cannot use this VPC peering connection. That is a limitation. One limitation. Second limitation is VPC peering is a non-transitive peering. So the non-transitive peering means, let's assume you have VPC A, VPC B, and VPC C. VPC A has communication with VPC B, okay, and VPC B has communication with VPC C. Directly, VPC A don't have communication with VPC C. Can these communication happen if I have any instance in VPC A? Can it directly communicate with VPC C? The answer is no. So VPC peering is a non-transitive. If you want to enable communication between VPC A to VPC C, yes, you create a peering connection and you enable communication between those. So VPC peering is a non-transitive peering. And what are the steps? Right, what is the process? What are the steps involved in this peering creation? First, you go to requester, create peering connection, give a name, select your local VPC. Where is your another VPC? Is it in same account in same region, or same account in different region, or it is in different account in same region or a different region? Right? So once we create peering connection, one connectivity is going to establish. Now you switch to or you log into that acceptor VPC, go to peering connection, actions, accept request. Now peering connection status will change as active. Once peering connection is active, so then you need to go to root tables and you need to update your root tables here in Mumbai as well as Northern Virginia or Singapore, whatever the region you selected and created peering. So what need to update here? The logic is simple. If you are in Mumbai region, you update with Northern Virginia CIDR range. If you are in Sydney or Singapore region, if you enable connectivity, you select this Mumbai region VPC CIDR and you update root tables there. So this is a process for VPC peering. And this elastic IP address is also part of the VPC, security groups also part of VPC, and network ACLs also. We already discussed about security groups in our EC2 interview series, interview video. This elastic IP addresses gives a fixed IP address for our EC2 instances. We can create elastic IP addresses in Mumbai region. We can associate to Mumbai region EC2 instances. So the security groups runs or creates within the VPC only. Security groups act as a firewall at instance level. Same way, network ACL act as a firewall at VPC level. Right. So subnet level, sorry. So whatever the subnets you have, you add all those subnets, you create a network ACL, you open required traffic. What are the traffic you want to allow? Only open that specific traffic ports. If you want to, you can set to any conditions also at network ACL. So basically security groups are stateful. You have to take care about inbound rules only. But network ACLs are stateless. You have to take care about inbound rules as well as outbound rules. And you need to associate subnets here, and one subnet can be part of one network ACL at a time. And how this network ACL evaluation works. So network evaluation works, lowest rule number is going to have highest priority first. Lowest rule number will have highest priority. So the evaluation will happen from higher to low, and whichever is blocked with lowest rule number, the traffic is going to block. So that is a network ACL concept. And guys, if you think I'm going a bit fast, you in YouTube video, we have an option to reduce the speed. And also, if you think these videos are helping you, informative, so please take some time and please subscribe to this YouTube channel. Okay, on top of this network ACL, we have an option called VPN connectivity. Basically, this VPN, virtual private networks, establish a tunnel between our network to the desired network, corporate network or AWS network. So again, in organization, how we are going to create side-to-side VPN connectivities, or let's assume you already have an organization, there are some firewalls now. You need to enable communication to this VPC from your on-premise with the help of private IP address only. You want to access the resources, so then how we can. So for that, first step is customer gateway. So create a customer gateway, and whatever the um, IP address your firewall contains, you give that IP address and create a customer gateway. Step two, create virtual private gateway. Whenever you are creating virtual private gateway, it will ask us what is the ASN number you want to default. Just go with the default ASN. If you have any custom ASN, you can give that and just give a name and create. Once you create this um, customer gateway and virtual private gateway, you go and create side-to-side VPN connectivity. So click on create VPN connection, whatever the virtual private gateway you have, select that, whatever the customer gateway you have, select that. So then you want to go with the BGP protocol. So then just select dynamic and scroll down, create VPN. Now automatically two tunnels will create and you can verify the tunnel status. So both are in down state. The reason we just created a VPN connection, we have not configured anything in the firewall. If you want to configure firewall in our that organization contains, so click on download configuration. Our organization may contain a vendor, right? A firewall vendor like a Bracuda or FI Networks or Fortinet or SonicWall or WatchGuard or Palo Alto Networks. So based on your organization firewall manufacturer, you select this and select what software it is contains, then download whatever the file or configuration file downloaded here. You share this configuration file with your networking team or firewall department. So they are going to configure the settings at firewall end. So then automatically these tunnels are going to up. When tunnels are up, we can access all the resources. So this is a process for hybrid cloud or hybrid environments. And another option regarding this VPC only. So that is AWS Network Insights. In this AWS Network Manager, there is a service called AWS Network Manager. There is a useful option called Reachability Analyzer. So again, how we can expect a question on this Reachability Analyzer? So the question is, hey Avinash, like you have an EC2 instance in one VPC and you have another EC2 instance in the same VPC, but both are not able to communicate each other. You want to verify where the communication is struck. Okay, so in that scenario, you can create this reachability analyzer. So YT test, and where is the source? Is your source is instance, right? What is the source type instance, and what is the source? Select the source, and what is the destination? For example, if this EC2 instance is not able to access internet, select internet gateway and select the internet gateway you have and which protocol it is using. Create and analyze the path. So it is going to send some pocket, source address, destination address, it is going to pick and it is going to do the analysis. Also from same instance, if you are not able to connect with another instance, you go and select here. Or if you are not able to access something over the peering connection, which peering connection you have, you select that peering connection or network interfaces. Or if you have any transit gateways, you can use that. Okay, so then simply create and analyze path. I'm going to choose this internet gateway and I'm selecting custom VPC gateway, create and analyze path. So now it is in pending state and the path is going to analyze and it will give us the reachable status, whether it is reachable or not, and click on analyze path. Okay, so then confirm. So now it is analyzing the path. Okay, it's going to take a couple of minutes. So it will tell us why and where it got struck, what is the reason. Okay, right? So here you see this is traffic cannot reach over the internet gateway when the source address is not paired with public IP address and all. So currently the reason this jump server is in stopped state. You see this, it's in bad state. That means it's in stopped state. Whenever this instance is in stopped state, can we access internet? Can it communicate with internet gateway? No, right? So it's saying the reason. If the same EC2 instance is in running state, yes, it is going to analyze a path. So for troubleshooting purpose, for testing the connectivity, so you can use this network manager reachability analyzer, and it tells us why we are not able to access, where it got struck, whether it is you can observe here whether it is security network interface problem, security group problem, ACLs problem, root table problem, or internet gateway problem. So it tells you. Right. So that is another helpful tool. And also we have another component here called transit gateway in VPC. So this transit gateway is advanced options for this VPC peering. So if you have only like two or three VPCs or around four or five VPCs, yeah, you can depend on VPC peering. But let's assume you have hundreds of the VPCs and you want to enable communication between all that hundreds of VPCs. So how we can do? So for that, we can use this transit gateways option. Transit gateway act as a hub and spoke model. So it is going to enable communication across multiple VPCs. So even I think there is a diagram AWS transit gateway um, in AWS official documentation. So if you're using now right. I've seen it somewhere. VPC pairing versus transit gateway. Okay, I have seen a diagram. Yeah, this is for peering. Okay, and this is for transit gateway. This is not the actual diagram I want to. I'm talking about. In AWS official documentation itself, we have a AWS transit gateway. Okay, I'm not able to find that, but you see here. So this is a transit gateway. This is acting as a communicator for this VPC A, VPC B, and VPC C, right? So yeah, so it acts as um, a hub for to enable communication. So yeah. So again, there is a video available in our YouTube channel for this. Transit gateway. I'll add that video in this. I'll add that video link in this video description. You can refer that. And also, I'm going to add this VPC um, videos I prepared. Also, I'm going to add as a video description. So please spare some time and please go through that so that you can answer all these questions. Again, practice is a key for this VPC module. I want you to spend some time and practice instead of theoretical things. All right, that's it for this video, and I hope you find this video informative. And please spare some time and please subscribe for more videos on this AWS interview series or any other services. And see you again in next video. Thank you.